Number 1 says to prove that quadrilateral MATH is a rhombus and then prove that it's not a square. So there's basically two parts to this question. So the first part is just prove that it's a rhombus. So if you remember, to prove either a rectangle, rhombus, or a square, you have to first prove it's a parallelogram, which means opposite sides are parallel, so they have the same slope. So I'm just going to find the slope of all four sides. So the slope formula is y minus y over x minus x, and I'm going to do side MA first. So I have 1 minus 5 over 1 minus a negative 2, which would give you a negative 4/3. I'm going to do the opposite side from it, so TH should give me the same slope. So we have a 5 minus 1 over 3 minus 6. Again, it gives you 4 over negative 3. Remember, it doesn't matter if the negative's on top or in the middle and the bottom, it's all the same thing. It's really just negative 4/3. Okay, so let's do the other two sides. The slope of AT, so let's see, 5 minus 5 over negative 2 minus 3, which is 0 divided by negative 5. That's a 0. It's crazy looking 0, which is really just 0, which makes sense because it's a horizontal line, and when you have a horizontal line, the slope is always 0. And then MH should give us the same slope of 0, so let's just show the work for that one. MH, so 1 minus 1 over 1 minus 6, which gives you 0 divided by negative 5, which again reduced down is just 0. So right now we know it's just a parallelogram because opposite sides are parallel. Remember, we're proving it's a rhombus, so we have to think, okay, wait, what makes a rhombus different than just a parallelogram? Well, all four sides are congruent, but you only have to show that two sides are congruent. Two consecutive sides, those two sides next to each other. So I'm going to do AM and MH. Well, how do I show that two sides are congruent? Well, I would use the distance formula and show they have the same length. So I'm going to find the distance of AM. So that's the big square root. Remember, x minus x squared. So negative 2 minus, I'm starting with point A when I do this. So negative 2 minus 1 squared plus, I'm going to go back to point A, so 5 minus 1. And you put all of that in the calculator, just don't type the square root button. And when you put it in the calculator, you get 25, and the square root of 25, if we reduce it, is just 5. And now we have to do a side that's consecutive to it, adjacent to it. So I'm going to do MH. See, it doesn't make sense to do a side across from it because that really would just be proving it's a parallelogram. So you have to do two sides next to each other. Okay, MH. I'm going to start with point M. So it's x minus x. So 1 minus, where's H? 6 squared. And then I'm going to go back to point M. So 1 minus 1. And same thing's going to happen. You're going to get a 25 under the radical, and the square root of 25 is 5. So the first part, just proving it's a rhombus. We can say, therefore, a rhombus is a parallelogram, because that's what we proved in the very first part, showing that opposite sides are parallel. So rhombus is a parallelogram. With, and then we go more specifically, what did we do for rhombus, which is right here. We showed that the consecutive sides, the distance was the same. So rhombus is a parallelogram with two consecutive congruent sides. Two consecutive congruent sides. So this whole worksheet, the first part is just proving whatever you have, which we've done in all the other lessons. Now we have the new part. Okay, so this says prove that it's not a square. So when you do this, I look at the diagram and I say, okay, why is this not a square? Well, because I don't see right angles, right? There's no right angles. So then I think, well, how can I prove that? What formula could we use to prove that? Well, remember, right angles, you have what kind of lines? You have perpendicular lines. And if you have perpendicular lines, what do you know about the slopes? The slopes are negative reciprocals, right? Well, look at the slopes for the consecutive sides. Let's look at AM and MH. Okay, where's AM? Here's AM, and MH is 0. Are they negative reciprocals? No, they're definitely not. That's showing that that you don't have right angles. You don't have perpendicular lines. So sometimes you have to do another formula to show the work, but in this case, because we already have done the slope, the work's already there. So really it just turns into, for number one at least, just writing another conclusion explaining it, not necessarily showing more work with a formula. So I usually write two separate conclusions, like in this case one for the rhombus we already did. I'm just going to write another conclusion here, explain why it's not a square. So what was it, MATH? Okay, so MATH is not a square because you don't want to just say because it doesn't have right angles, because you want to go to the slope formula and look at what that showed. Because the slopes, you could either say, okay, there's two things you could write. The slopes of consecutive sides are not negative reciprocals, or you can say that the consecutive sides are not perpendicular. So actually I'm going to write the consecutive sides, meaning the sides next to each other, right? The consecutive sides are not perpendicular. Okay, there we go.